Hello friends, welcome back. In this video, we'll talk about microservices components. So basically, we'll talk about the modules that helps you in developing a highly modularized, robust, and scalable microservices based application. All right. And this video is very important for those who really want to understand how microservice architecture. Now, let's have a quick look at the components that we are going to cover in this video. So we'll begin by looking at the Spring Cloud Config Server. Then we'll talk about Netflix Eureka naming server. Then we'll talk about Hystrix Server, which we use to build circuit breaker pattern. Then we'll talk about Netflix Zuul API gateway server. After that, we'll discuss Netflix Ribbon, which is a client-side load balancer. Then we have Zipkin, which we use for distributed tracing. And then we'll talk about ilk stack trace. Finally, we'll talk about the communication channels that microservices use, like REST endpoints and MQ messages. Now let's begin the video. Spring Cloud Config Server. So let me give an example actually first. Let's think of like you have one microservice and you need to maintain some properties for this particular microservice, like all your database information, your server port number, name, and everything. So what you do, either you create a .properties file or you keep all your properties in YAML file, right? So basically you need to maintain one copy of these properties for your microservice. Now in case if you have another microservice, you need to maintain same copy or same properties for your second microservice as well. So similarly, if you have n number of microservices, you need to maintain n number of copies .properties file or .yaml file to keep the properties, right? Now, so config server comes into picture here in this case. So what config server does is it stores all your properties either in a Redis cache or in a Git repo. So you can put all your properties in a Git repo, and then this Git repo can come. So config server can communicate with the Git repo using something called webhook. So whenever you make any change in your Git repo, we have something called webhook. It will communicate. It will let your config server know that there is some change happened in the Git repo. So it will get the latest values or updated properties from the Git repo, and those properties will be available for your microservices. So any microservice needs any sort of property, it will directly communicate to the config server and it will ask for the property, right? You can have another application running on port number 8081, and this particular application may ask for the same sort of details, maybe database username or password. So again, this particular application will also communicate with the config server and will ask for the property value, right? So config server, it basically helps you in keeping all your properties in one place. It could be your Git repo or could be a Redis case, right? So you don't need to maintain the same properties or multiple copies of same data for each microservices, right? So basically it provides a better way to keep or store your properties. All right? So your Spring Cloud Config Server provides a centralized configuration and it runs on port number 8888. Now, if you have to use your config server, you need to make use of @enable config server annotation to enable the configuration or the Spring Cloud config server. And you also need to add this particular dependency in your pom.xml file. This is how your piece of code will look like. You need to make use of @enable config server annotation. All right. So for any application that wants to communicate with the Spring Cloud config server, need to maintain this properties. You see here. So basically you can think of like I have one web service, so I need to use bootstrap.properties file, and here I'll put the path or the URL of the Spring Cloud config server. Why? Because I want to mention that if I need any sort of properties, my application, my web service will go and talk to Spring Cloud config server to fetch the property value. All right, let's move forward. Now the next component is Netflix Eureka naming server, which is also known as discovery server. All right, so now let's think of a scenario. For example, your service A wants to communicate with the microservice B or microservice C. So in order to allow the communication, you need to maintain the microservice address with its port number either in your configuration file or in your code itself, right? For example, if you want microservice A to communicate with the microservice B, you need to maintain this particular IP address and port number somewhere in your properties file or in your code itself. Say, for example, if instance A or service A wants to communicate with the service B, you need to maintain the IP address somewhere, correct? So as your microservices grows, it becomes very typical to maintain these details. So here, to sort out this particular problem, we have something called Netflix Eureka server, or which is also known as discovery server. So what it does, like for each your microservice has something called registry client. So basically it's a dependency that you need to add in your each single microservice, and each single microservice will register itself into the service discovery. Now whenever any service wants to communicate with any other service, it will just go and talk to the Eureka discovery server, and it will get the service URL from the service registry, and then it will just communicate with the respective services, right? So let me show you how it looks like. So when you start your Netflix Eureka discovery server, it runs by default, it runs on port number 8761, and currently if you see, we don't have any of these services registered. So now once you start your microservices, as you can see here, we have got 4 microservices registered, and you can see the availability, the status of each single microservices and the number of instances. So basically you have same microservice account services running on 2 different port numbers. So here is your microservice URL and the port number. So account service is running on 2 different port numbers, 8091 and 9091. You have got customer service, 2 instances up and running on port number 9092 and 8092, right? So similarly, you have all your microservices registered here in the Netflix Eureka. Netflix Eureka is a discovery server. It maintains a registry, and if you have to use, you need to make use of @enable Eureka server annotation in your microservice, and you need to add this particular dependency that you can see here. Now, because this is a server, now your each microservice has to register itself, right? So you need to make use of @enable discovery client annotation so that your microservice can register itself into the service discovery registry. All right. Now the next one is Hystrix Server. Basically, we use Hystrix Server design the circuit breaker pattern. It avoids complete failure of an application, and it does this by using the circuit breaker mechanism. So I will explain what is circuit breaker mechanism very soon. Now to make use of circuit breaker, you need to make use of the @enable circuit breaker annotation in your code, and here is the dependency that you need to include: Spring Cloud Starter Netflix Hystrix. Okay, so this is how, once you have the dependency, you need to make use of this particular annotation to enable the Hystrix server, right? So now, as I told you, we use this one to enable the circuit breaker approach. So what it does, so to enable the circuit breaker approach, we use something called @Hystrix command annotation, and we define a fallback method. So whenever a particular function or your web service is down, you define a fallback method for each function, and then that particular method gets invoked. So whenever your service is down or it is not available, you will see a pre-configured message. So in case if you see here, we are calling a particular function, and if that particular function is not available at the moment, so it will just go, your Hystrix circuit breaker or Hystrix server will go and call the fallback function or fallback method, and it will return the response from the method itself, and it will stop the further communication. All right, now let's take an example here. So if you see here, you have your web service and you have your Hystrix server embedded with it. So basically you have added the dependency to enable the Hystrix server. Now you have got multiple web services, and each web service has circuit breaker. So when I say circuit breaker, in the sense, you have defined the @history command and a fallback method for each single service. Now let's think of a scenario. Because you have defined circuit breaker or basically fallback method for each microservice, in case your microservice is down, your Hystrix server will know about that, okay, this particular service is not available, and it will invoke the fallback method. So it will just go and get the response from the fallback method, and it will return the response to the client. Let's move forward. Now let's talk about the Netflix Zuul API gateway. So let's have a look at this particular example. So here you can see we have got different sources or different clients trying to communicate to the web services. But here in between we have something called Netflix Zuul API gateway. So it works in between your client and your microservices. So each single request and response has to pass through the API gateway, right? So basically when you work on a normal like program, you can directly call your microservices just by putting the microservice URL and the port number. But when you work in a production ready application, you need to make use of the Netflix Joule API gateway, and all your request has to pass through the API gateway. So basically your API gateway would be running on a standard port number, and then your clients will make a request to the API gateway, and then from there your API gateway will call the respective web service. For example, there is a user using a browser and wants to communicate to this particular microservice. So it will pass its request to the API gateway, and then API gateway internally will decide it may communicate with the Eureka discovery server to fetch the microservice URL and the port number, and then from there it can allow the communication. And similarly, to pass the response to the browser, again your microservice response will go through the API gateway itself, right? So your API gateway has got many other features that we'll discuss maybe in the next video. As I told you, it handles all the requests and perform the dynamic routing of microservices. It also has an inbuilt load balancer to load the balance of all the incoming requests from the client. Now, to make use of the Netflix Joule API gateway, you need to make use of the @enable Joule API Joule proxy annotation, and you need to add this particular dependency in your microservice. And these are the settings that you need to make in your application.properties file. Your application name, Joule API gateway, runs on default port number called 8765, and here you need to mention the URL. Now to allow the communication, so basically now you want your communication to your microservices through API gateway, you need to make some change in your client application or in each of your microservice. So you need to configure your microservice. You need to tell your microservice, okay, that access to my microservice should be through the API gateway. Let's move forward. Now the next one is Netflix Ribbon. It is a load balancer, but it provides load balancing at the client side, right? So apart from load balancing, it also provides some of the other features like fault tolerance. It can communicate with the different protocols, caching and batching. Now let's have a look at this particular diagram. So here you have your client sending request to invoke a user service instance 1 or 2 or maybe 3. So we have got your Netflix ribbon in between, and it communicates with the Eureka server. So your Netflix ribbon works with the gets the details about the microservices from the Eureka server and maintains a local copy, and then from there it decide, okay, there is a request from a client and the client wants to invoke a user service. Now your ribbon will decide, depending on the workload, it will itself will decide which instance to invoke. I will show you a working demo in the next video. But the sole point of this particular thing is that Netflix Ribbon provides a client-side load balancing. All right, let's move forward. Now the next one is Zipkin, which we use for distributed tracing. Zipkin provides a mechanism for sending, receiving, and visualization traces. Basically, you can view the logs in a better manner. It helps gather timing data needed to troubleshoot latency problems in service architecture. We use something called Seluth dependency with the Zipkin, and it basically provides a trace ID. Make use of the Zipkin server, we need to make use of @enable Zipkin server dependency, annotation, and here is the dependency that you need to include in your microservice. So once you start your Zipkin server, this is how it looks like. From here, you can choose the microservice for which you want to see the logs. And once you click on any of this pane, you will see the depth here. It says depth 4. So basically, your request was transferred to the 4 different functions. And once you click on any of these, you will see more detailed logs. So like this with the timing and with the actions. So from message client to message service and then from client. So you will see more detailed log, right? Now the next one is ilk stack trace. Again, we use this one to view the logs in a better manner. So ilk stands for Elasticsearch, Logstash, and Kibana, which is a UI. So basically how your ilk stack works is like you have your log file. So you need to define about your log file into the logstash.config file, which is, so basically logstash is a server, and here you need to define the input file. Okay, go and read my input file from my microservice. Say for example my or service a.log file. So your logstash will read the data from your log file, and yes, like because you can have multiple microservices and each microservice can have its own log file, so you can mention all your log files into the logstash.config file, and then your logstash server will start reading logs from all your log files. So it can read the logs from one single file, or it can read the logs from multiple log files. You just need to define those log files into the logstash.config file that we'll see in the demo. Now your logstash server, it will read the data from, or it will just collect the data from the log file, and it will convert the data into the JSON format. Okay, and then from there we have something called Elasticsearch. So Elasticsearch, it basically helps you in finding out the logs, a particular log. So basically it provides a mechanism to search and analyze the logs. And then we have Kibana, which provides a UI to visualize and manage the logs. All right, now let's have a look at this particular diagram. So here you can see you have microservice 1, 2, 3, and each microservice is writing in a separate log file 1, log file 2, and log file 3. So here you have logstash. So in your logstash.config file, you need to mention about each single log file that. So you mention about each single log files. Then your logstash will collect the data from each single log files, and then it will transfer the data, like it will convert those logs into the JSON format, and it will transfer to the Elasticsearch. So Elasticsearch, basically it provides a good mechanism or a better way to search the logs. You can analyze or search the logs in a better manner by using Elasticsearch. And then your Kibana works, it communicates with the Elasticsearch, and it provides a better visualization of the log files. So we'll see Elasticsearch working in the next video, but I hope you have got the idea here. All right, so what you see on the screen is a very standard approach or a way to design a microservice. So here on top you have got your user interface, and then we have Netflix Zuul API gateway. Then we have Netflix Eureka discovery server, and here we have Netflix Eureka config server properties file or the configuration details. And each microservice has got Hystrix circuit breaker enabled here that you can see. And each microservice also has Eureka client. So because I told you Eureka discovery is a registry and each service has to register itself, so we need to make use of Eureka client. So this particular client will make sure that this particular service is registered into the service registry, and the communication is through the REST endpoints. We have Zipkin and Seluth dependency to collect the logs in a better manner with the all the spans and depth that we can see, right? And here we have got that each our microservice is writing in a log file, and then we have configured all our log files into the logstash.config file. So logstash will read the logs from the application log and convert the log into a JSON format, and it will pass to the Elasticsearch. Elasticsearch, which is again a server which provides a search and analyze capability, and then it communicates, it passes the data to the Kibana. So Kibana is a front end, you can say it's a dashboard where you can see the logs in a more visualized manner. So here in this diagram I have put all the possible components that can help you in designing a more modularized or scalable, robust and stable microservice. All right, so in the coming videos we'll go through the each module one by one. We'll see an example also. Okay, so thank you for watching and bye for now.